All right, so let's jump in. So myself and Corey are going to be presenting on 3D printing. Corey has his printer set up in the corner over here, and he's going to be doing some demos and whatnot throughout the day. So stop by and check that out. So one thing that's really cool about ham radio, is ham radio is a hobby of hobbies, right? And so when I became a ham, which was only about 4 years ago now, one of the first things I discovered was that it's also a convergence of hobbies. So you can have one hobby like 3D printing, and all of a sudden you think all kinds of stuff you can do with ham radio. And so, and then when I met with Corey, we started talking about the various projects that we've done in the past, and thought that would be a really cool topic. So let's jump right into it. So we're going to talk about the history of 3D printing, which when I was researching this, it was pretty interesting because there was a lot I didn't know. Like one thing I didn't know is just how old 3D printing is, how mature it is. So we'll get into that. Then we'll talk a little bit about various printer types, various vendors that are available, price points. And we're going to talk about methods of printing as well as the materials that we use for printing. Then we're going to talk about where you can find 3D projects. So it used to be you kind of have to design your own stuff, right? So you have to fire up a CAD program and design your own stuff, and then convert it. And now there's thousands and thousands of projects out there that are just ready to go. So you can either just download the file, convert it into whatever your printer's code is and print it, or you can pull it into a CAD program and modify it. They call that a remix. And so I've done a ton of that, because I'm not a mechanical engineer. I'm a computer engineer, but when it comes to the mechanical stuff, I'm a hacker at best. And so it's great if you can start with somebody else's design and just modify it. All right, so then we'll get into creating and monitoring projects, converting it to the printer code, some best practices, lessons learned, and then we're going to get into some example projects. And if there's questions, feel free to just raise your hand as we go through it. And Corey and I are going to be co-presenting. He's going to do a demo a little bit on as well. Okay, let's talk about the birth of 3D printing. I did not realize that it went all the way back to the 1980s. I thought this was like a fairly recent thing. Now the commercial, and especially the home use of 3D printing, the amateur use, if you will, does date back no more than maybe 10 years. But the commercial applications of it, of course, go way back. So 1981, in fact, so Dr. Hideo Kodama came up with a rapid prototyping machine that created parts layer by layer. And that is the exact same way that today's 3D printers still work today. And he was using a resin polymerized by UV light. Now, that is not the most common technique for printing today, but there are still printers that do that, and we'll talk about that. 1986, the first stereolithography patent, I say that 10 times fast, or SLA. You'll hear SLA a lot. That's still a term that's used in all the printers today. It was filed by Chuck Hull, who is widely credited as being the inventor of 3D printing. And he created and commercialized SLA and STL, which is the file format that all the designs use today. 1988, Carl Deckard licensed selective laser sintering, or SLS, which is another type of printing, uses a laser and uses powdered material and turns it into solid structure. I don't think that there are any commercial, kind of off-the-shelf printers that do this, but I could be wrong. You know of any, Corey? Yeah. No, I don't think so. That sounds pretty exotic to me. 1989, Scott Crump patented the fused disposition modeling, or FDM, and founded Stratasys, which is one of the major players in the 3D printing industry, even to today. And then in 1989, Chuck Hull's company, 3D Systems Corporation, you'll remember Scott from a little bit earlier there, released the SLA1 3D printer, which was the first kind of commercial printer that used SLA. So then comes the 2000s. So we're skipping forward about 20 years. So this stuff had to bake, and percolate. And a couple of really major things happened in the 2000s. Now, of course, additional companies were founded. The materials were being refined all through that period, all the way through the 90s. But right in the 2000s, the biggest thing that happened was open source. Everybody familiar with open source? You know what that is? Yeah. So open source really opened the world, not just to 3D printing, but to computing in general, right? Because that's what was the birth of Linux, the birth of 3D printing, all kinds of different technologies, which previously would have been proprietary, commercialized types of technologies, are now openly available. not only for download and for use, but for modification. Right? So you have a lot of people all of a sudden crowdsourcing the development of things. So 2005, there was an open source project called RepRap, which I had never heard of until I researched this. They created a 3D printer that became the inspiration for all the printers that came after it. And one of the coolest things about RepRap was that the notion is that you can use this printer to make another printer, right? So you can print most of the parts for yet another printer using that printer. And today that's true. Like when I got my printer, the very first thing I think I ever printed was an improvement for my printer, which was a spool for the filament, which we'll get into in a little bit. Right? So that's a pretty cool concept, I think. And to this day, there are people that are making their own 3D printers. Now, obviously, you have to go out and buy the hardware components like the servos and the hot end. We'll get into that in a minute. But you can 3D print a whole lot of the pieces, and you can actually create one yourself, you know, if you're fairly creative. So mid 2000s, most of those 1980s patents became public domain by default, right? Because that's what patents do, unless they're renewed, obviously, but they weren't. And so all of a sudden, all that proprietary technology became public domain, which means that other companies could start using it without having to pay for it. 2009, MakerBot, which to this day is a major force in 3D printing. They introduced an open source DIY 3D printer kit, and you can still buy a kit from them if you want to build your own. And they created Thingiverse. We'll talk about Thingiverse a little bit here. That is the premier source of free printing materials or designs. So we'll talk about that a little bit here as well. And then in 2011, Ultimaker created a commercial printer that was based on the RepRap project. Okay, so today in the future, if you look at this picture, that is a 3D printer that prints concrete. How cool is that? Oh, wow. They're literally 3D printing buildings with concrete, you know, and they can print these things in like a day or two. And it's pretty amazing. Go out to YouTube and just type in concrete 3D printing, and you can go down that rabbit hole for hours. There is cool stuff going on there, right? So we're starting with little desktop printers, like the one that's in the corner back here. That's Corey's printer, all the way up to these massive, gantry-powered concrete printers. So pretty amazing stuff. The mold and tool market alone is valued at $5.2 billion today. Think about that. That's quite a commercial opportunity. And it's projected to grow to $21 billion by 2030. So this is a huge, huge business. And the end user parts market, like us that are going around and buying stuff, is projected to grow to $19 billion by 20,390. Okay, maybe that's a title. That's theory. Yeah, looking way into the future. So what's next?
I won't be around yet.
No, yeah, I don't plan on being around either. AI. Now, one of the things that I do, so what I do professionally is I'm a cybersecurity researcher. And AI, of course, not only is everybody all over AI, but we're really focused on it, especially from a security perspective. So that got me thinking about what you could do with AI and 3D printing. So I could see it, in a couple of years being able to say, print me a desk stand for my FT5DR. And it goes out and it finds the design and feeds it to your printer, and off you go. So, that's.
Can you print your car too?
Print your car?
Brand new car?
Maybe.
Nice.
Yeah. Teslas are probably mostly 3D printed. Of that. Good question. Okay, so let's jump into the different types of 3D printing. Fused filament fabrication, or FFF, and fused disposition modeling, or FDM, are the two most popular ways of doing it. And this uses a continuous filament. So filament is like thread, right? Thicker, obviously, but it's a spool like you see on the top there. Just a spool of material, typically plastic, different types of plastic. And we'll talk about those different types of plastics. Sometimes it can be plastics that are filled with wood or even metal. It's crazy. We'll talk about that. So basically, it just feeds that in to what they call an extruder, also known as a hot end, that melts it. And then around that, you've got a structure there that moves in basically three dimensions. So you've got, the print head, then you've got the extruder. The extruder is on a gantry that gives you X and Y, and it can also go up and down for Z. So it's a three-dimensional thing, and it basically just, when it's told to, it starts feeding molten material onto the bed, which sticks, and then just builds it layer by layer by layer. Pretty cool stuff. All right, so SLA, stereolithography. This was one of the earlier designs. It's not as popular, but it's pretty darn cool, in my opinion, in that what it does is basically it uses a liquid resin, and instead of a hot filament that melts things, it uses a laser or sometimes a UV light to harden the resin. So it basically targets it, and it still builds it layer by layer, but it's basically doing it in a vat of liquid resin. Very exotic, but you can buy these, and they're pretty cool. I don't have one, but yeah, maybe someday we'll get one of those. So usually it's ultraviolet light that does that.
Are there any advantages?
The advantages? I don't know. Corey, do you know?
Yeah, much higher resolution.
Higher resolution.
Yeah, the part almost smooth.
Cool. Yeah, I will admit Corey has done probably 100 times more printing than I have, so that's why he's here too. He knows a lot more than I do. Okay, so this is the printer I have. And just as an example, it's the Creality Ender 3 Pro. So Creality is a Chinese company, and they were a leader in creating very inexpensive printers aimed for the home and hobbyist market. And I bought mine probably 3 years ago over at Micro Center. Micro Center had so many of these printers that they have them going down the aisle stacked up like 4 and 5 tall. That's how fast they were selling it. And they probably still are, but selling at that clip. So let's just start at the top, and I'll just take you through the various pieces of it. So we already talked about the filament. My apologies, so I'll try to do both screens here. But the filament at the top, that feeds in basically down through here, right here into the extruder. The extruder is basically just a little gear that clamps onto the filament, and then it's a little stepper motor, right? And that just advances the filament one tiny little bit at a time, and it feeds it into the hot end. So the hot end, as the name implies, is hot, and it's an end, which means, so what happens is the filament goes through the hot end, which melts it. So as the extruder advances the filament through the hot end, then this molten stuff comes out the bottom, and it's just a nozzle, basically. And you can get different types of hot ends for different materials, different sizes. So if you want to print wider filament or narrower filaments, there's a whole selection. And they all use the same kind of threading. So it's just a matter of threading a new filament or a new hot end nozzle into it. Then you got the motors. So we have the X stepper motor here, which moves it, actually moves it this way. And then we've got the Y stepper motor, which basically just moves the build plate around. And then the Z stepper motor, which then moves it the other way. So we've got 3 different stepper motors that are moving it this way, this way, and then the build plate also moves around. Okay, so that's how it gets the, all the motion that it needs. And I'll have a power supply naturally. That's pretty straightforward. Typically, you just plug that into AC, and off you go. There's always a display and the main board, which is a little processor. That was really one of the other things that led to a lot of the development in 3D printing was the availability of low-cost controllers, which kind of brought the price point way down on these things. Now, one thing I will say, you'll find this, but if you buy your own, I bought the kind of the cheapest one that was out there because I didn't know what I was going to use it for at the time. But what happens is, the first thing that happens is you go, oh, I should have probably bought this. And so you continue to upgrade it. So it's kind of a trade-off. You can buy a cheap one, and then you can either print upgrades or buy upgrades, or you can just spend the money ahead of time and get all those upgrades already in the printer. So for example, Creality sells the Ender 3 Pro, and then they've got like the, do you remember the model numbers?
Well, the whole Ender 3 line, they've got V1s, V2s, V3s, S1s. I mean, I can't keep track of all the models they keep coming up with, but like you said, more and more upgrades.
Yeah. So the point is, if you have the budget, just buy the best one you can buy because you're going to wind up spending that money anyway. And the other downside is if you don't buy it ahead of time, then you have to install it, which can be a whole other process. A good example of this is that one of the critical things in 3D printing is having level bed. which makes sense, right? Because if it's going around and around, it's got to be level, otherwise it's not going to stick and it's going to look wonky and all that sort of thing. So when you buy this printer out of the box, it does not have an automatic bed leveler, which means that you have to come down here and see these little wheels. You have to turn these wheels and try to get it all level, which you can do, but it's very time consuming and you have to do it a lot, you know, because variations in temperature and all sorts of things can change your bed level. So you can buy a series of different automatic bed levelers. Now they're not perfect. It's not like this hydraulic thing that just automatically just push a button. You still have to start with a relatively level bed. But what the automatic bed levelers do is they have a little sensor and it just sits, it attaches right to the side of this, you know, the hot end here. And basically just comes down and it just touches the bed and samples the bed in, I don't know, 20, 25, whatever it is, different spots. And then that goes into a matrix. And when it prints, then it knows about all those little minute variations in the bed level. So that's what a bed leveler is. And there's all kinds of different bed levelers that you can buy. The point is, if you get an upgraded printer, it probably comes with one already. Whereas I didn't do that, so I had to go and buy one, install it, get it all working. You have to upgrade the firmware on the bloody thing, which is a whole nother process. And then I used that for about a year, and then I found a better one. So then I upgraded to the better one. So anyway, the point is, you know, buy a better printer if you can get one. Okay, let's talk about manufacturers. So Creality obviously is the one I have. I've had very good luck with it. It's been very reliable. Lots of upgrades available. Like I upgraded when I first got it. Forgot to mention that. So if you look down here, excuse me, see the controller display? Literally, it's just a black and white display, and it's got a little wheel that you have to turn. Now, what I say about 3D printers is you can plug them into a computer or a Raspberry Pi and have that control it for you, which does obviate the need for, you know, a better display on the printer. But sometimes you just want to be able to quickly hit print or, you know, whatever you're trying to do. So I upgraded mine to touchscreen, which was a whole nother deal because I had to get not only the hardware, but again, then I had to find the right firmware that would work with the touchscreen, with my printer, with the 3D or with the leveling system that I had. It took me probably a couple days to find the right firmware to make that all work together. Anyway, okay, moving on. So Creality is great. Prusa Research, another huge one. Don't know much about them. Corey, do you know Prusa at all?
Yeah, they're bigger in Europe, but yeah, they're a big one.
Bigger in Europe. Good to know. Ultimaker, of course, they were one of the very first, maybe the first producer of 3D printers. I believe they're USA too. So that's a good American company, if I remember right. MakerBot, another one, and Stratasys. I don't know much about that, but any of those are probably good. Obviously, if you can get one that's got wider market appeal, like I would probably stick with Creality, MakerBot, or Ultimaker, because those are the three that I know come up a lot, have widely available parts. All right. Any questions so far? Yes, sir.
The upgrades you did, if you were to buy something equivalent today, how much did that cost?
I would say maybe 500. So yeah, I paid maybe $2 something for the original one, but I've done all kinds of upgrades, you know. So yeah, like 2 bed levelers, the touch screen. I added the standard Ender 3 only comes with a single motor for moving it up and down. So I added a second one, which makes it a little the resolution better. So I added that to it, and that's not just the motor, but another screw drive and all kinds of stuff. That was a fairly involved one. And again, if you buy a better printer, it comes with both of those motors already. But yeah, probably around 500.
Mark, if you don't connect it to a computer, how do you feed it the design you want it to print?
Oh, good question. So the question was, if you don't connect it to a computer, how do you get the design that you want to print into it? I can just speak to my experience, which is with the Ender, and the easiest way is it takes a little micro SD card, like the one you put in a camera, and you can just copy the G code, which we'll get into in a minute here, the G code file onto the SD card, and then you stick it into the printer, and then it shows up on the user interface. You just say print this. So, good question. That's also how you upgrade the firmware. That's just
I understand that some of these printers are cloud-based so that you can't use them unless they're connected to the internet, and then you've got to use the company's website to do all your designs. Which ones are not like that if you don't want to share your designs with some company in China?
So the question was, some of the printers are cloud-based, which means that they have to be connected to the manufacturer's cloud service in order to print and do designs. So the question was, which ones of these are and aren't that way? You know, the Enders are not, because they're designed to be standalone. Corey, do you know of any of the cloud-based ones?
Yeah, Mark Forged is a big one. Mark Forged is more of a commercial type 3D printer. And they monitor what you are printing, everything is in the cloud, and they limit what you can print. For example,
Mark Forged.
Yeah. I don't think you can print gun parts with those ones.
Yeah, print gun parts. Okay, good to know. Okay. Yeah, I wasn't aware of that limitation at all, but yeah, I'm mostly limited to the home versions of these things. Okay, moving right on. Okay, back to filament types. So everybody starts with PLA, which is polylactic acid, which is a bioplastic made from corn. I did not realize that until I did this research. So it's kind of cool. It comes from corn. It's very user-friendly. It sticks well. It's easy to print with, so everybody starts with PLA and, to get their cut their teeth or whatever. And they print some really cool stuff. They go, all right, I really got this down. Then they move to another one of these materials and they realize they're starting over, which I'll talk about. But PLA is great. The only downside of PLA is that it has a relatively low melting temperature, which makes it more user-friendly. That means that, bless you. That means if you leave it, like say if you print a radio holder for your car and it sits in the sun, you may come back to a puddle or severely warped. So it's not good at higher temperatures. So you don't want to put it in the sun. It's also not terribly UV resistant. So yeah, so that's good for doing stuff that you're going to have in your house. Like if you want to print a little plaque with your call sign on it or something, it's great. But don't take it in the field. PETG is the next one down. That was the next one that I tried. That's polyethylene terephthalate. Yeah, I'm not going to try to pronounce that. PETG is good. It's more UV resistant. It is trickier to print, but it's a lot more resilient. It's a higher temperature material, so it's a little more heat resistant and warping resistant. So that's a good one to do next. So that's kind of what I went to when I started printing stuff for, like, I'm a big soda guy, so it's on the air. And so I started printing antenna stuff, like I made a Moxon antenna. We'll talk about that in a little bit here. And so I printed all those parts with PETG just because it's better for taking outside. Then if you really want to get hardcore, like Corey, you can get into ABS. I do have some ABS. I've not printed with it yet. It's much higher temperature. It's much more finicky. You've done ABS. Yes. Oh, he started with ABS. He's hardcore.
Bad idea.
Yeah, so it has a high melting temperature, very strong prints. Most of the stuff that you buy that comes out of China that's plastic is probably ABS, just to give you an idea, right? So it's very tough, very resistant to temperatures and UV and all that kind of stuff. But when you print it, it creates noxious fumes. So you have to be in a very well ventilated area. And typically you wind up buying a shroud or a cage, if you will, to go over your printer to keep the temperatures up. Because otherwise, if the temperatures start to drop, then it doesn't print. You have to stop and start over again. So ABS is not for your casual 3D printer, which may include me. We'll see. I'm going to try it probably over the holidays. A couple others. Polypropylene is flexible. Is that what you print your phone cases with? TPU, which is not on this list. There, this is just by far from being an exhaustive list. But yeah, there's other materials that are more flexible that you can use for doing all kinds of crazy stuff, like printing phone cases, you name it. Right. So, and again, the more exotic the material, the harder it is typically to print with. Is TPU tricky?
It's super slow. You have to print like 1/10 the speed.
Super slow. Okay. Yeah, and that's one thing I should mention. The higher end printers are going to be faster. The one that I have, like the Creality, I printed a little case for one of my Raspberry Pis that looks like, it's kind of cool. It looks like a Macintosh server case. It's really cool. It's only about like this big by this big. It took 2 days to print that thing. Just to give you an idea. So these things take a while. But anyway, there's also really cool exotic materials. Like I mentioned earlier, some that are metal filled, some that are wood filled, and they literally look kind of like metal and kind of like wood. But as you might guess, those are very abrasive. So you have to have a very tough nozzle. Otherwise, it's going to go burn right through it. It's kind of like using sandpaper. Right? So you have to buy a really, really tough, like titanium or whatever it is, nozzle, right, for those materials. And you can't really read it. We'll post all these decks on our website, by the way. But there's a link down here. It's got a really nice resource that will give you a matrix of all the materials and all the pluses and minuses and things you need to know about it. All right, so let's talk a little bit about finding projects to print and modify. Yes, sir.
Can you real quick, just talk about the cost of consumables?
Yeah, question was cost of consumables. Relatively cheap. Like PLA, for example. One of this cool thing that you'll find, like I use, what is it? The slicer, Cura. And what it will do is when you pull in a design and you set all the parameters, you can tell it what material you're printing with. You can even put the cost of like per spool, and it will tell you what it's going to cost to print the project. And so, for example, that piece that I just mentioned for my Raspberry Pi, I think it cost me like $1. Yeah, not including pain and suffering and the weight.
How about the electricity?
Yeah, the electricity. Well, they're not too bad. You know, these are a couple $100 watts, so you know. Or a ham radio. We all have gadgets, so that's probably just a drop in the bucket in our electric bill. But yeah, patience is required. Obviously, some of the more exotic materials cost many times more, but still, you know, it's probably much cheaper than going out and buying your own, you know, off the shelf somewhere. Yes, sir.
What fee did the plastic you use for that $1 item?
How much?
What was your
My feed material? That was PLA. Yeah. PLA is generally the cheapest, you know, because it's made from corn. And it's very, very popular. Yes, sir.
All of these filaments you run out of eventually on the spool.
Yep.
Do you have to go through some sort of an elaborate fusing process to get the next spool on?
Oh, good question. Yeah. So the question was that you're eventually going to run out of these materials, right? So what's the process of getting new material on? It's actually pretty straightforward. Let me go back to the picture of the printer. So the filament comes down into the hot end, and literally it's just held by the extruder by a little gear, and it's got typically a little lever. So all you do is you heat up the hot end so that it's melting in there, and you just push the lever, and you can just pull the little filament out. And then you just put the new spool on, which is kind of like putting a thread, a spool of thread on a sewing machine. Very straightforward. Matter of fact, one of the first things I did is I printed a better version of this bracket that was easier to put the spool on and off with. And then you just literally just run it back down through the extruder, which is just kind of like threading a needle, only not that hard. Just through these gears down into the hot end. And again, you have the hot end hot. And so what I do is I just typically just give a little bit of pressure until I see the old stuff done, because you'll see it coming out, and the new stuff coming out, and then you're ready to go. So pretty straightforward.
So it doesn't hurt to have two different sources of filament. If you're printing something large, maybe you want a different materials characteristic in one part of the piece you're printing.
Yeah, good question. And that's a great point. A lot of projects will use more than one filament, either different types, different colors, because who wants to print the same color for everything, right? And so there's a couple things you can do. If you buy this printer, you're going to be swapping it out. You know, it could be just as easy as swapping out the filament for a different color, or if you're changing materials, you may have to swap out the nozzle too. But there are higher end printers that have multiple filament or multiple hot ends, right? So as you get into the higher end of the market, then you can have like a couple different colors, and it just swaps them out. Right?
On a finished piece, then you wouldn't have some sort of a break in continuity.
Right, exactly. So with the finished piece, you wouldn't have a break in continuity. Now, if you're doing a simple print, you're just changing colors because you're doing it later at a time. that's pretty easy because you can just stop it, change the filament, and restart it with a new color. But what oftentimes the more complicated prints, like I was looking at doing one for my nephew, that's one of the Star Wars battles cruisers. And it's got all kinds of different parts. I mean, it's like putting a puzzle together. And so most of those parts are printed individually and put them together later. Excuse me. Yes, sir.
So far, you've been talking entirely about filament printers. I've been looking, because I want to do smaller things with more detail, I've been looking at getting an SLA printer. And do you have any material on those?
The SLA printer. No. You know anything about that?
I've never used an SLA printer. I know they are higher resolution. I don't like all the liquids and how slow they print. So I wanted a larger print volume. So I've never used SLA.
Yeah, so.
Yes,
Yeah,
I think
no.
Micro Center has a couple of those as well.
Oh, do they?
Yes.
I'll check into that. All right, moving right along here. Okay, so got your printer, ready to print something. What am I gonna print? Where am I gonna find it? So there's all kinds of resources out of. My favorite is Thingiverse, which is the one on the bottom there. But there's a whole list there. Some of these sites like Colts 3D, for example, have both free and paid projects. The projects aren't typically terribly expensive, but you know, some people, they spend a lot of time designing these things. So I guess it makes sense that they might want a few dollars to pay them back for doing that. But anyway, yeah, so like if you go out to Thingiverse, that's my favorite spot because virtually everything, I think everything on there is free. And like if you go to Thingiverse and just type ham radio, you'll be amazed at how many projects come up. I mean, everything from microphone clips to antennas to, you know, excuse me, radio cases, you name it, it's out there. So yeah, one of the first things I printed was a little thing with my call sign on it. And I used PLA, and the other day, yesterday, I was putting together some examples to bring to this, which we have back on the table, and I dropped it and it shattered into about 6 pieces. So there's PLA for you. Don't drop it. Yeah, ham radio keys. A couple of the giveaways up here, Corey printed. He printed CW keys. They're really cool. Yeah, incredible amount of stuff. All right, creating and modifying. Oh, that's the thing that broke. Right there. So you can use a variety of computer-aided design systems. Everything from a commercial like AutoCAD. AutoCAD makes a kind of a kid's version called Tinkercad. AutoCAD makes Tinkercad. Okay. Yeah. Tinkercad is what I started with. It's designed for kids to be able to create their own designs. And for me, that was perfect because it's easy. Right? They took a lot of the complexity out of it and just kind of give you the basics. So if you're going to start and you've never done anything with CAD, I would recommend Tinkercad. Excuse me. And then you can get into some of the more advanced ones later on, like AutoCAD, Blender, and so on. But again, if you just Google, you know, go to the web and Google 3D printing CAD, you'll come up with all these different options. Tinkercad is nice too because it's web-based. So you just go up, you know, it's all done through your web browser. You don't have to install anything. It's very straightforward. All right. Well, I kind of already talked about my experience. Oh, this is your experience. So why don't I give you the mic?
Switch it. I'm gonna skip that. That's okay.
Yep. Stop share. You hit the stop share.
Check. Okay. Everybody hear me okay? Perfect. At my screen?
Yeah.
Yep. Not going into presentation mode. There we go. Okay. Let's see, Mark brought up a lot of great stuff. I just wanted to start with my experience with 3D printers. I started way back in 2015 with an inexpensive kit. It was actually a clone of one of the Prusa i3s. And you can see from the pictures, it was not a pretty printer, but it's still actually printing today. Unfortunately, it's tethered to an old Linux machine, so. But it does still technically work. Learned a lot from that printer.
Right.
Yeah, there we go. It was just a little delayed. Okay, so I'm gonna demo today, slicing, going and getting a file you find on the internet, slicing it, getting it ready for the printer itself. Most 3D printer manufacturers will give you some sort of a slicer with their printer. Kira, I think is the one Mark was talking about, is the one that Creality uses. I think it's a fork of an open source. Prusa also uses a very similar slicer. I use Slicer itself, which is another open source free one. You get into the paid versions, and they give you some pretty fancy features, which I've never used. But when you start printing and you are printing an item and it has like a weird overhang or something, sometimes you need a support underneath it to print it, and then the support's removed afterwards. So we're gonna switch over here to printables. Okay, printables.com is one of the ones that you had mentioned. It's similar to Thingiverse. This one is hosted by Prusa, which does the open source printer out of Europe. Adam Kimmerly, K6ARK, does a lot of really cool prints. So I'm going to grab this paddle that he has produced here. This is the one that is going to be one of the giveaways here. It is printing on the printer as we speak. So I've downloaded these files, and here's his instructions on how to set it up. So now I'm switching over to the actual slicer program itself. Slicer is for that Creality 3D printer. And I'm going to open up the files. There's the bottom. There's the top. And there's the paddle levers themselves. So here, zoom in a little bit. Can everybody see that okay? These files are, as I downloaded them, these are how they've been presented. The first thing I do is what I look at is how they're going to sit on the build plate. So as you see, as I flip this thing over, there's an awful lot of red. Red's not good. It's not going to stick right. So I'm going to take that one part and I'm going to flip it 180 degrees so that it sits flat. Now, if we look at the bottom, oops, still not quite right. So let's move it up just a touch. There we go. Blue. Blue is good. That means it's just going to sit flat on the build plate. You want it to sit flat and it's going to print up from there. So I'm going to reset my view. The type of material I'm currently printing that with is PETG. PETG is much more flexible than the PLA Mark was talking about. The PETG gives in this case, the paddle the ability to flex. It has a live hinge in it, in these little tiny hinge points, which I don't think you can see on that. So it's all ready to go. I'm going with the default settings, which I highly recommend if you're going to get into 3D printing. Before you start tweaking, there's so many variables. Try it with the recommended variables first and see how it goes. So I'm hitting the slice button, runs through a process, and this is producing the G code for all the individual layers. And it says, I think you were talking about how much is this gonna cost? It says right here, it's gonna use 13 grams of filament. That's less than 4 meters, so. If that roll of filament costs $20. It's not much. You're gonna pay more in time for the little screws, the little sockets and things like that to print, so. At this point, you save it to file, like Mark was talking about. That printer right now is not tethered to anything, so I just save it to an SD card, plug in the SD card, turn it on. Through the little interface, you select the file you want to print. And hit print, you're off to the races. So. Let's switch back over to. Examples of files to print. It doesn't like my hotkeys. Like Mark was saying, antennas, antenna parts. I mean, the list of things you can print for ham radio goes, it's endless. I literally say, I tell people your imagination is your limitation. I don't have a great imagination, so I'm limited as to what I can print. A lot of what I do is download. Mark had mentioned Thingiverse. That's probably my go-to as well. Printables.com is probably my second one. I've never actually paid for a print. I've seen the ones that you can buy. I've never run across something that I've wanted that badly, I guess, to print. I've played a lot in Tinkercad and I've gotten fairly proficient in it, designed quite a few parts. I've published some of them on Thingiverse. A lot of people have downloaded them. There's some of the more advanced things that I've created I haven't published. I created a multi-tool for bicycles. And this process is great that you can demo it on PLA, but it needed it to be much stronger. So I printed them on a different printer that I don't own to be printed out in Kevlar and nylon. So you can actually use a wrench to put wheels on and off and things like that. It's still very light. It's gotten to be very popular. It's easier than ever. The one thing I can stress is you need to be patient. Especially when you're getting up to speed and you're learning, there's going to be a lot of failures and you just kind of go back to the drawing board. If you're going to pick a printer, I highly recommend you look at the support you have out there. Forums, the manufacturer itself usually has some pretty good support structure in place. And that's about all I have. The one thing that you had brought up that I saw in your slides was free places to print. Public libraries are great. I actually started with Denver Public Library years ago before I got my first one, and they did print a few things for me, and then I decided I kind of wanted to be in control of my own stuff. So that's why I got started. There's got to be a lot of questions here. Any questions right now?
Yeah, I was surprised that Jefferson County Libraries doesn't do that for whatever reason.
Really?
Yeah. Or if they do, they don't advertise it on any of their websites. Does anybody know? Have you ever seen 3D printing at any of the Jeffco libraries? But yeah, as you can see, Bravo, Denver, and there's also commercial places that'll like if you have something really exotic, it might be easier just to send it to them and have them.
Yeah.
Good, Jim.
At the library, you don't run the printer, you
No.
give them the file.
You give them a file on a flash drive. And the last time I did it, it's been 2015 since I did it. It was a slow process. It was usually a couple weeks to get the file. And the quality varied wildly.
Probably volunteers running it.
It is, I think, but it was great. It got me started. So
You just pay for the library, you just pay for the filament then?
actually, my experience was it was totally free.
Okay.
Yeah. George?
I think a lot of people might ask you this, if you're worried about the easily informed PLA filament, what would you suggest using? It's not going to create that view. Looking for a photo image.
George had a great question on, printing something that you're not worried about, the low melting temperature and the possibility of deformity. The next step up, in my opinion, would be PETG. It does take a higher temperature just to print, and it is more resistant to warping once the product is finished. That's my recommendation.
Yeah, the only downside of veggie that I found is it's finicky, just getting it started, just getting it to stick to the build plate to begin with is tricky. We were just talking about this last night, I think, and we didn't really talk about this, but what I found was that using the purple Elmo balloon that comes in a glue stick is miraculous. It's just the coolest stuff. It is cheap. And I literally just I have a glass build plate. I just coat it with the glue. And that made all the difference for me with PETG.
Yeah, I've played with different tricks trying to get it to stick. And if you look next to my printer, there's a glue stick.
Some people like painter's tape too, the blue painter's tape.
Yeah, what I like about the glue stick is it wipes right off.
Yeah, or you can rinse it off. Just like with my glass, I can just take it off and I can take it to my sink and it just washes right off.
Thank you very much.
I think, guys, so we've got 10 minutes. Oh, we got one last question.
So my encouragement, thinking go to these free websites, see all the cool things you can make, because that will get you hooked.
Yeah.
That's.
Lots of free websites, lots of great YouTube videos.
I don't know if you're a craftsman or machinist. I used to say, if I can draw it, I can go. Right? Not anymore. If I can draw stuff that I could not machine, that I can make out of PLA and one of the plastics.
For sure. All right, break time. So we got 10 minutes. So, oh, we have more time.
One quick one, I don't remember the name of the outfit, but they're up at Longmont. They manufacture 3D printers.
Lulzbot. Lulzbot. They're open source printers. Yeah, they're great printers.
And I don't know if they still do, but they had public tours. And one of the things we saw back at that time, they had a room full of printers.
Print farm, yeah, they got a print.
Printing, and what they were doing is they were printing printers.
Yep.
All right, then we took them downstairs and then they took the parts that couldn't be printed, like the steel rod or the movement.
Cool.
And their icon